Hello, class. Welcome back. Today, we're going to go ahead and continue with homeworks 8, 9, 10, and transition towards 11, 12, and 13 for this week's homework. On homework 7, we started, we were approaching the idea of calculus, right? Finding our rates of change and whatnot. And this is the first section, right? So let's go ahead and get started. For your homework and for the exam, right? Whenever you have to show your work, there's a long way to find a derivative, right? By the definition. And then there's a shorter way, right? There's a shorter method by applying different rules. If I specify to use the definition of the derivative, you must show the derivative by that method. If you do not, you will not receive any credit for it, right? So the formula that you need to go ahead and apply would be f of x, right? Your given function is equal to the function at x plus h minus f of x all over h, all right? All over h. So let's go ahead and plug that in for our example, right? They want me to go ahead and find the derivative, right? Whenever you're finding the derivative of a function, right? You would specify that by the tick, by the prime, all right? Tick you have. So I'm going to go ahead and find my derivative. And I'm told, all right, that the first part I need to go ahead and find, right? So I want to go ahead and dissect this in pieces. All right, so the first thing you need to go ahead and find is f at x plus h. What this means is you get the given function, and wherever you have an x, you're going to replace it with an x plus h. All right, so in other words, x plus h plus 10. All right. So what I'm going to go ahead and do now to simplify this is distribute as far as I can simplify, right? They also wanted me to find f of x, but we know what f of x is, right? That is just the given function. So at this point, I can go ahead and apply everything that I need, right? So to find that derivative, it is the function at x plus h, which we determined was 5x plus 5h plus 10 minus f of x. But just like we mentioned before, right, in the previous video, be sure to wrap this up in parentheses, all right, because you need to go ahead and distribute that negative if applicable all over h. Right. What can I do here to simplify? Right, you can go ahead and distribute this negative into there. Right. Eating here. This is 5x plus 5h plus 10 minus 5x minus 10 all over h. And you should notice what should happen is things should start canceling out, right? Things should start canceling out. This 5x goes away with this 5x. This 10 goes off with this 10. And I'm left with a 5h over h. All right, you'll notice that with these, whenever you're applying the definition of derivative, if you can, factor something out from the numerator, all right? You should be able to factor out an h from the numerator, all right? And whenever you were to factor that out, you should cancel out. But I only have one term here in my numerator, right? So these cancel out, leaving with just 5. Right? So this here's my final answer. That is the derivative of my function. I have another one, right? Oh, this is the one we just did, right? This is the one we just did. All right, find the derivative using the definition, this given function, and then find the slope of the line's tangent to that, right? In order to go ahead and apply that one, right? Just like before, right? We need to go ahead and apply the definition of the derivative. Right. So the first thing I'm going to go ahead and do is find f of x plus h. right, which gives me 8 h squared minus 10 h. Definitely simplify this even further, right? Specifically this part here, I can apply FOIL to that, right? That's technically what I have here is that's what I have, and what I went ahead and did here is apply that negative 10 into the x plus h. Simplifying this gives me 8 times x squared plus xh plus hx plus h squared, right? But that gives me 8x squared plus 2xh plus h squared, right? Leaving me with 8x squared plus 16xh plus 8h squared. Right, I can go ahead and bring down what I didn't use. All right, I wasn't using that just yet. Reason for me to keep writing everything down. Let's see if I can go ahead and combine any more like terms. What's this 10? This should be a 10h plus 15. There you go. And I think that's as far as I can go, right? All these are unique terms. And right, so I need to go ahead and now do minus f of x, all right? Right, so we know f of x is just a given function, all right? So applying everything by the definition, right? It would be that part there minus the original function, which was 8x squared minus 10x plus 15 all over h. Right, over h. What I can go ahead and do now, right, is distribute that inside. So this here gives me 8x squared plus 16xh plus 8h squared plus 10x h minus 8x squared plus 10x minus 15 all over h. Right, and a few things cancel out here, right? First of all, the 15s cancel out. The 8x squareds and the 10x's, right? 10x's. Right. So this here, right? So after you go ahead and subtract and you combine like terms and things cancel out, right? You're gonna have terms in your numerator divided by h. Right? And this is the part where I was stating you want to go ahead and factor the top, right? You're gonna notice that everything in the top has a variable in common, which is h. So then if I factor out an h from the top, right? And then what happens? It just cancels out, which was my goal, right? Which was my goal. I'm now left with 16x plus 8h minus 10. But you notice that, right? You go ahead and notice that whenever you're applying the definition of the derivative, you're going to get this far where you have something with x and with h after it cancels out with the denominator, right? And probably a coefficient at the very end, right? What you need to go ahead and do then is take the limit as h approaches 0 of your derivative function, right? So in other words, take the limit as that limit approaches 0, right? And we learned that in our previous section. That just states wherever you have an h, you're gonna tend to 0, meaning the derivative of your original function, right, is 16x minus 10. Whew, 16x minus 10. Very, very nice, right? So that is the derivative. That is the slope at any given point of this function. At any given point, I just found it, right? At any given point. The question might ask you, hey, I want you to find the tangent line, right? The slope the rate of change at a given point, right? So this is part B, right? And this here is going to be part C. Let's do part B, right? We'll go ahead and do part B together. So for part B, I have my slope, right? You can even say this is M, right? You can say that's M because it is, right? Slope, college algebra, right? It has that. And they're giving me a point, right? The point says find the slope of the line's tangent to this, right? Find the slope to that. All you need to do there is if you have a y in your function, you're going to see later on that we are, right? That's eventually going to come up. You plug this number in, right? And if you have an x, you plug that in. And that's going to give you the slope at that given point, right? I don't have any y's, but I do have that x, right? So I want to find the derivative at that point, the slope at that point. So this is going to be 16 times -3 minus 10, all right? 16 times gives me -58. So that is my slope. That is my derivative. That is my rate of change at that given point for that given function. It is -58. All right. And for part C, right, you would just do the same thing, right? You would just plug in 5 into the slope, into the derivative for that x, and then, right, that's going to give you the answer. Right. So that was the long way, right? That was by definition. You are going to have that on your exam, all right, and definitely in your homework as well. So be sure you know how to approach those. Now we're going to find the short way, all right, which it's known as, the first one we're going to go ahead and learn, excuse me, is the power rule. The power rule, right? The power rule. Let's go ahead and give an example. Simple example, all right? You have a function, let's just say f. This is your function, x cubed. You go ahead and apply the power rule, right? You're going to go ahead and derive this function. Instead of doing all of that, right, by definition, what you're going to go ahead and do is bring this number to the top, to the front, and subtract it by 1 upstairs. Right? So in other words, the 3 came to the front, and then I had x raised to the 3 minus 1. All right, so meaning that here ends up being 3x squared. That would be my derivative. All right, let's go ahead and do another one. All right, let's just say we have f of, no, we'll say g. X is equal to 3x to the 10. Right? Same as before. This number is going to come to the very front, all right? And then you're going to subtract the top one by 1. So in other words, if there's something occupying a space in the front, and there's already something there, right? They're going to be multiplying x to the 10 minus 1. So in other words, my derivative for that function, 30 x to the 9th power. If you wanted to go ahead and check that it's that, right? It might take you quite a long time, especially we're dealing with to the 10th power, right? You can go ahead and apply the definition of the derivative. You find out it does give you the exact same thing, right? Right. So now let's do a few of them, right? Let's go ahead and do a few of them, right? And the cool thing about this is that you can keep taking the derivative of the derivative, right? So for example, if you have, we'll do another easy one, right? 2x to the 3rd, right? If I asked you, hey, I need you to take the derivative of this, right? Okay, so h prime of x is equal to, right? I'll bring that to the front, and then minus 1, right? So 3 times 2 times x to the 3 minus 1. This here gives me 6x squared. Awesome, right? I could have asked you, hey, I want you to find the second derivative. I want you to find the second derivative. You would apply the same rule again. Right, so then this here ends up being 2 times 6 times x to the 2 minus 1, right, which that second derivative just ends up being 12x to the 1 power. right? So let's just say if I were to say, hey, I want you to find the third derivative. Right? And you'd ask yourself, hey, what? There's nothing up there, but technically there is, right? Technically there is. There's a 1, right? There's a 1. Right? Like before, you're going to bring that to the front. Minus 1, right? So this is going to be 1 times 12 raised to the x 1 minus 1, all right? Which is 12 x raised to the 0. And what do we say in our first homework assignment? What is anything to the 0 power? 1, right? This is going to be 12 times 1, which is just 12. All right. Another way you can think of this is if you're taking the derivative of a coefficient with just an x, all right, whenever you derive this, it is just the coefficient in front. Right. It is just the coefficient in front. Right. Another one I could even ask you, right, is, hey, I would need you to find the fourth derivative, right? What's the fourth derivative? What's the derivative of a coefficient? What would be the derivative of 12 if there's no variables involved? There's no x there. It is 0. The derivative of a constant of a coefficient by itself will always be 0. Right? So I can say, hey, y is equal to 101. The derivative would just be 0. Okay. What about negative 101 over 3? Still a coefficient. It's still just a number by itself. It has no x, meaning the derivative of this, that would be 0. Okay, so enough practice, right? Enough practice, right? Enough practice. I'm asking you to find the first derivative, right, of this given function up here. All right, I'm going to let you can go ahead and pause the video. All right, you can go ahead and pause the video. And you'd find out that this here gives me 40x to the 7th minus 30x to the 4th minus 18x squared plus 4. If I were to have asked you, hey, I'll take the second derivative again. Right? Go ahead and take the derivative of that again. Right? So this here would be 280x to the 6th minus 120x to the 3rd minus 6x plus, ooh, that's a coefficient, right? That goes away, so that's just 0. Very nice. All right, if you see that I ask you the derivative of f at x equals 1, all right, that means you're going to go ahead and look for the one that you saw it for, which was up here, right? Which was this one, right? That's f prime, the first derivative. And you're going to plug in 1 wherever you see that, whenever you see an x. Okay, that's fine. We know how to do that. Then you would just compute and simplify. And whatever answer you get, that is your final answer, right? So this here ends up being -4. You would do the same thing with the second derivative, right? It's saying, hey, I need you to find the second derivative, but for every x that you have, plug in 0 instead. That gives you 0. So these are really fun, right? They're like little puzzles and stuff. So for this one, right, I'm asking for the fourth derivative. And whenever you get to the fourth derivative, you let t, or whichever variable you're dealing with, be 0. That's cool. All right. So if they're looking for y to the 4th, right, I got to do 1, then 2, then 3, and then 4. All right. So y prime is going to be 4t to the 3rd minus 14t, right? Y double prime would be 12t squared minus 14. All right. Y to the 3rd would be 24t. Then y to the 4th would be 24. Right? You may ask yourself, hey, I don't see anywhere where I can plug in t, so what's my answer? That it is. If there's nothing you can plug in, then just read what you have. Right? Read what you have. And what is it? It's 24. So that right there would be your final answer. All right. That right there would be your final answer. You may ask yourself, hey, well, what do I do if I'm dealing with numbers? Do I still need to subtract by one? Right? Yeah, you do, right? You would still follow the same rules, the same power rules, right? You would still go ahead and follow the same power rules, with the exception that if you have fractions with variables in the denominator, you're going to want to move those to the top, for example. Q of x is equal to 2 over x squared. No, it's too many 2's. 2 over x cubed. All right. One thing you need to go ahead and learn that we learned in the first homework is bring that to the top. All right. You need to rewrite this. This is just 2x to the negative third power. All right. Once you have it in that form, you can go ahead and apply the power rule. Just be careful with the negatives. All right. Okay. Power rule states that if you take the derivative, this number to the front, and you do minus 1. All right. So in other words, this is negative 3 times 2 times x raised to the negative 3 minus 1. All right. So this here ends up being negative 6 x to the negative 4th. Right. It's negative. So you're moving further to the left. Right. So you just be careful. Right. You wouldn't write negative 2. Right. Even though instinctively we may want to do that. Right. We just need to be careful with what we're doing. All right, so for this example that we have here, everything looks fine with the exception of the last one, right? I'm going to want to go ahead and rewrite the last one, right? So that means this here would be plus 5 times x to the negative 2. Then I can go ahead and apply the power rule, right? So taking the first derivative, the derivative of a constant is 0. For the second term, this is 1 over 2x raised to the 1 over 2 minus 1, right? Because that came to the front. This comes to the front as well. So this would be negative 3 over 4 times x to the negative 3 over 4 minus 1. Minus 10 x to the negative 2 minus 1. All right, that's what I have here. All right, and let's focus on the exponents, right? Let's go ahead and focus on the exponent. Oh, 0 is just 0, so that can go away. All right. Looking at those exponents, those fraction exponents, I have 1 over 2 x raised to the 1 over 2 minus 1. All right. But what we had, let's focus on 1 over 2 minus 1. 1 over 2 minus 1. We had learned in college algebra, right, that in order for you to add or subtract fractions, they both must have the same denominator, right? We also learned in college algebra, right, that any integer, any number is divisible by 1. All right. So any number like 3 can be rewritten as 3 over 1. All right. And we're going to use that to our advantage. All right. So in other words, 1 is the same thing as 1 over 1. These two need to go ahead and have the same denominator. So I'm going to multiply this by 2, this by 2, meaning I have 1 over 2 minus 2 over 2, which this ends up being negative 1 over 2. All right. So that is what ends up, this is what that ends up simplifying down to. All right. So in other words, my new exponent is negative 1 over 2. All right. Let's go ahead and now focus on this one here. All right, let's go ahead and focus on that one. So negative 3 over 4 minus 1 over 1, right? But if you see the shortcut, it's always going to be, if it's minus 1 or plus 1, where you're always going to be using the denominator of the other fraction. So minus 4 over 4, right? Because 4 over 4 is divisible by 1. Or you can do it, you know, you can try the further steps like we did, right? To see that what it gives me. You need to find out this gives me negative 7 over 4. Right. And then the last one is just negative 10 x to the negative third. Whew. All right. Whew. So this here is my derivative. So here's my derivative. Moving on. So we went ahead and learned, applying the power rule, right? By applying the power rule, right? You're going to ask yourself, hey, what if I got multiple terms and those multiple terms are multiplying each other? Something like this. Something like this. What do I do? Right? Do I have to follow this out? All right. Do I have to distribute this into this into this? Then this into this into this, and then do power rule? You can, but it's going to take you a very, very long time. Right? It's going to take you a very, very long time. Right? And there's a shortcut to this. Right? There's a shortcut to this method. Right? And the shortcut to that method is known as the product rule. All right, the product rule, where you're gonna have two things multiplying one another. You're gonna say this one is F and this one is G. Right, so everything here is F, everything here is G. The product rule tells me if you want to take the derivative of two things that are multiplying, right, you're going to do the second times the derivative of the first plus the first times the derivative of the second. Right? And there's a reason why I'm doing it this method, right? It's going to help us compact things later on. All right. So the first thing you would want to do is write F. F is t squared plus 4, 7. And then you're going to find F prime, the derivative of that. All right, so while applying the power rule, right, this is 2t plus 4. Okay, so far so good. Then you're going to find G. All right, G was the other term, which is 3t squared plus 6. And then G prime, right, is 6t. Okay, very, very nice, very, very nice. All right, and then, right, so once you do that, don't stop, right? Once you do that, don't stop. You're just getting pre-work ready, right? All we're really doing right now is getting pre-work ready so we can go ahead and apply the product rule, right? The product rule tells me I'm going to get G, which was 3t squared plus 6, and multiply that with F prime, right, which was 2t plus 4, plus F, right, which was t squared plus 4t plus 7 times G prime, which was 6t. And this right there is my derivative. All right, this right there is my derivative. If it was simpler, I would have asked you to simplify this, but I'm not really worried. I'm not really gonna ask you, to simplify this and get rid of the parentheses. You'd be fine, right? If you were to leave it like this, and I can clearly see that you understand how to apply the product rule, I'll give you the credit necessary, right? I'll give you all the credit necessary, right? So hey, you found your derivative, f prime of t, right? If you were to find f prime of 1, right? This is algebra, right? I know all of you can do this. You would plug in 1 into all of that, simplify, and that number that you get would be your final answer. Right, that right there was known as product rule. We're going to do another product rule, right? One more. All right, there are two things that are multiplying. All right, this is my F, this is my G. All right, so we said F is t squared plus 3t 7, meaning F prime is 2t plus 3. G is 6t squared plus 4, meaning G prime is 12t. To find the derivative of two things that are multiplying, it is G times F prime plus F times G prime, right? Meaning my derivative, right, is, and the F that I'm using here is different from the original one that was giving in my function. So try not to get those two confused, right? The f that I wrote here is just a label, an identifying label, all right, for the definition. All right. So this means that my derivative, right, of the original given function is g times f prime plus f. That's the original one, right? The one I used to identify times g prime. And that, again, right, I said I wouldn't expect you all to simplify this. Oh, and you may know that sometimes my open math, right, like any other program, it can be very, very picky with the answers that you plug in. If you showed me the correct work and it leads to the correct answer, because in calculus, you'd find out that there's so many ways you can write an answer, all right? There's just not one definite way to give the final solution, all right? And if I were to read all your work, see all your work, you did the appropriate steps, use the correct numbers, you'll get the credit, right? You'll get the credit. So you don't have to be like, hey, well, I get more credit if I were to simplify this all the way. No, you won't, all right? But it's always great to polish up on our math skills, right? Right, so we already found out what to do whenever we have a function that has two terms that are multiplying, more than two things that are multiplying, right? You apply the product rule. A question that you may have is, what do I do if they're dividing, right? That is known as the quotient rule, right? This here would be known as the quotient rule, right? Where you have two things that are dividing, right? The rule, right? The definition, whenever you have two things that are dividing and you want to get that derivative, right? It's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Wow. All right. Wow. The reason I wanted you all to memorize the previous one that specific way was because if you notice, it's the exact same formula for the quotient rule, with the exception that there's a minus for quotient, right? And as well as a g squared at the bottom, right? So just like before, right? Your top one is going to be f in your numerator, and g is what's in your denominator. All right, so your f would be 3x plus 5. Meaning f prime would be 3. G is 6x plus 4, meaning g prime is equal to 6. Applying this into the definition of the derivative, right? Of not the definition of the derivative, but the definition for the quotient rule, right? I get g 6 times f prime. Oh, no, wait. G is a 6x plus 4 times g prime, f prime, which is 3, minus f times g prime all over g squared, right? All over 6x plus 4 squared. With this one, with quotient rule, please pay attention. You do have to simplify your numerator. You do have to simplify. You simplify, right? Right. So simplify my distributing, right? So all it really is it's distributing, right? That gives me 18x plus 12. All right. And what I have here would be negative. What does that give me? I keep the negative, but I'm not distributing this into here. This gives me 18x plus 30 all over 6x plus 4 squared. Applying this negative into there, I get 18x plus 12 minus 18x minus 30 all over 6x plus 4 squared. My variables cancel out on the top. That's not always going to happen, right? It may or may not. It just depends on the problem. All right, 30 minus 12, that gives me negative 18 all over 6x plus 4 squared. And that right there was my derivative of the original function. right? Definitely go over those, right? Definitely go over those. Right, we'll go ahead and do another quotient rule, right? We'll go ahead and do another quotient rule, all right? Where we said if you got two things that are dividing, it is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. All right, we said the top is going to be f, so that's going to be negative 9x squared. F prime would then be negative 18x. G is going to be x minus 5. G prime, right? You may ask yourself, hey, there's really no coefficient in front of the x. Yes, there is. It's 1, right? It is 1. Right, now applying this to find the derivative of my original given function, it is the bottom, the derivative of the top, minus the top, derivative of the bottom, all over the bottom squared, which is G. With these, like I said, you do have to simplify it. You need to be very careful, right, with the negative signs, right, with the negative signs. All right, so my derivative here is negative 18x squared plus, what does that give me? Plus 90x plus 9x squared all over x minus 5 squared. And then on the top, I get negative 9x squared plus 90x all over x minus 5 squared. Sometimes you may have to factor the top because it may cancel out with the bottom. Let's see, what can I factor out from the top? Let me factor out a negative 9x. So that leaves me with an x minus 10 all over x minus 5 squared. Nope, nothing cancels out. So that right there would be my final answer. Right, that right there would be my final answer. Right, I left it as here. You could also left it as here. All right, but it does have to be simplified, right? You will not get credit if you leave something like this. Well, partial credit, right? But right, might as well just go the whole way, right? You've already done the difficult part, right? Just all right. And then we have a shortcut, right? A hint that I wanted to go ahead and introduce you to, right? So it can help you out in future problems, right? This little hint here, it's going to be very beneficial. You may see this, you got a term at the top, you got a term at the bottom, and you may ask yourself, oh man, I got to have to do the quotient rule, right? Not always, not always. And the hint here is you only have one term in your denominator, right? You only have one term in your denominator, all right? So what you do here is you divide everything in your numerator by that denominator. It means the same thing. Right? Moreover, we know that the square root of x is the same thing as x to the 1/2, right? And we can see, oh, that's where that assignment came from. Yeah, right. I wanted you all to have an idea for that to be fresh in our mind, right? Going into this upcoming sections. All right. So that means, right? Okay, that just means that, meaning my function, right? I'm still just doing pre-work. This is just 3x squared over x to the 1/2 plus 3x over x to the 1/2 plus 7 over x to the 1/2. Moreover, right, we said, hey, if we have things in the denominator, right, and we don't want them there, we move them to the top. So this here is 3x squared times x to the negative 1/2 plus 3x times x to the negative 1/2 plus 7x to the negative 1/2. We know that whenever two things are multiplying, right, whenever two things are multiplying, two variables are multiplying with the same base, the coefficients add, right? The exponents add, right? So then this is here is 3x to the 2 minus 1/2 plus 3x to the 1 minus 1/2, and the last one just stays the same, right? 2 minus 1/2, right? It needs to be the same denominator, right? So you would multiply 2 over 1 by 2 over 2, meaning this here would be 4 over 2 minus 1 over 2, 3x, 4 over 2 minus 1 over 2, plus 3x, 2 over 2 minus 1 over 2, and the last one still stays the same. Meaning, just rewriting this. I haven't even taken the derivative yet, right? I haven't even taken the derivative just yet, right? This here would be 3x to the 3 over 2 plus 3x to the 1/2 plus 7x to the negative 1 over 2, right? Ha ha. Right, if this was f of x, I can finally take this derivative. Right, this here would be 3 times 3 over 2 x to the 3 over 2 minus 1 plus 3 times 1 over 2 x to the 1 over 2 minus 1 plus 7 times negative 1 over 2 x to the negative 1 over 2 minus 1. Wow. All right. Wow, 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 wow. Meaning here I have, right, I'll let you go ahead and all, right, do these fractions, but because at this point, right, we should already know how to do this. All right, so you can go ahead and pause the video. I get my derivative. My derivative to be 9 over 2x to the 1 over 2, 3 over 2, the negative 1/2, minus 7 over 2, x to the negative 3 over 2. All right, so very, very nice, very, very nice. A lot of algebraic manipulation, right? A lot of algebraic manipulation. And honestly, that's the majority of points that are taken off in this class. The calculus concepts are pretty straightforward, right? The calculus concepts are pretty straightforward. The formulas are pretty, right, easy to go ahead and identify. But it's the algebra that always ends up, getting us, right? It's always the algebra, right? All right. So we're moving on now to part 11, right? It's lecture part 11. And it's known as the extension of the power rule, right? The extension of the power rule, right? Which is known as chain rule, right? Chain rule. We can an extension of the power rule, right? Which is known as the chain rule, right? And the chain rule specifies, right? It's an extension, right, of what we have. It's, hey, you're going to apply the same rules as the power rule, but the only exception is that now you're going to end up multiplying by the derivative of the inside of your parentheses, right? You're going to multiply by the inside of your parentheses. For example, right? So I'm going to go ahead and do a simple one. Let's just say I have x squared plus 1 to the 3rd power. Right, so an extension of the power rule, right? This is chain rule. I'm going to bring this to the front. I'm going to do minus 1. Right, so this here is going to be 3 times everything that you have in the inside stays the same. 3 minus 1, this gives me 2. Don't stop here. Times the derivative of the inside of the parentheses. All right, the derivative of the inside of the parentheses would be 2x. Right? You multiply these two together, and you find out that your derivative is 6x times x squared plus 1 squared. All right. Go ahead and apply that to the one what we just learned, right? So this here would be x to the 3rd plus 5x plus 7 to the 4th power. Right, power, I'm going to bring that to the front, minus 1. Copy down exactly what I have. To the 3rd power times the derivative of the inside. Don't forget the derivative of the inside. The derivative of the inside would be 3x squared plus 5. All right, and this one you can leave here by itself because you got more than 2 terms at the end, right? This is very, very, very nice. Right, excellent. This here would be the derivative of it. All right. Similarly, all right. Hey, what if I'm dealing with square roots? Can I still apply the extension? Yeah, definitely, right? Because you know what square roots are. That is just everything raised to the 1/2. So in other words, your function technically is parentheses 5x plus 7 raised to the 1/2. Ha! I can go ahead and apply chain rule here. This goes to the front, -1. All right, at this point, all right, this is 1/2, 5x plus 7 raised to the -1/2. Right, I did went ahead and did the fractions for the first few, but moving forward, right, I'm going to do them step by step. As in, you can pause the video. That's something, right, that we should already be familiar with. Times, right, derivative of the inside, which is 5, meaning, right, I can definitely multiply this to the front, meaning this is my derivative is 5/2 times 5x plus 7 raised to the -1/2. And that right there would be my final derivative. All right. So now you may be saying, what if I can apply chain rule to both of them, but also product rule? Is that possible? Yeah, it's definitely possible, right? It's definitely possible, and it is here. All right. Meaning everything here in green is a unit. And everything here in blue is a different unit. There are two things that are multiplying. So we said this is going to be F, and that's going to be G. And we're going to apply the product rule to this, right? And if you're applying product rule and you reach a point where you may have to apply chain rule, then it has to happen, right? So let me go ahead and write F. F is going to be -9x squared minus 2 raised to the 6th. The derivative of this requires me to do chain rule, right? So this here would be 6 times -9x squared minus 2. 6 minus 1 equals 5 times the derivative of the inside. I can definitely simplify this to and more. This gives me -108x times -9x squared minus 2 to the 5th. Whoa, right? I have G, right? G is 8x squared minus 7 raised to the 10th, meaning G prime here would be 10, 8x squared minus 7 raised to the 9th times 16x. Meaning this here would be what, 160x times 8x squared minus 7 raised to the 9th. Wow, right? Those are just the required steps to go ahead and find the complete answer, right? Because we still need to go ahead and apply product rule. All right, so the derivative of my function, all right, the derivative of this function here would be G times F prime plus F times G prime. And yes, you should distribute. I'm just kidding. You do not have to do that. You do not have to distribute. This is one full piece. All right, there. Wow, that right there's your derivative, right? It's a derivative, right? Right there's your derivative. Excellent job, excellent job. All right, meaning, hey, do I have to apply it for quotient rule as well? Yeah, you would, right? Yeah, you would, right? I'll go ahead and get it started for y'all. And let's see what it gets, right? So we know F is the top. F prime then has to be 2 times 6x plus 3 to the 1 times the derivative of the inside, which is 6, meaning this is 12 times 6x plus 3, right? There's only an exponent of 1 here, meaning you can technically distribute that into there. right? Meaning this here would be 72x plus 36 for f prime. G would be 10x plus 4, meaning G prime would be 10. Right? And that's as much of the setup I'll go ahead and give. You should, by this point, you should know you should have it saved on your notes, right? Very nice, right? So that was going ahead. That was applying chain rule, and then chain rule mixing it up with product rule and quotient rule, right? What we're going to go ahead and do now is look at exponentials, right? Exponentials, right? Exponentials, right? The derivative of exponential functions. And if you haven't done so already, I would highly recommend you download and print the list of derivatives I have in the course content part of the class, right? That's going to have all the derivatives you need to know for the course, with the exception of the trigonomic functions, right? With the exception of the trigonomic functions so far, right? So far. So here I have, right, I have this function, j of x, right? Remember this, if you need to go ahead and take the derivative of an exponential function, you're going to copy down exactly what was given, and you're going to take the derivative of the exponent, right? The derivative of the exponent, which is just 1, right? What you have is e to the x. Right, so that's going to be a great question, right? This is like an identity one. The derivative of e to the x is just e to the x, right? What about this? What if I need to go ahead and apply? Oh, here, let me go ahead and rewrite this. This should have looked like this because I'm taking the derivative. Like that, right? So hey, I need to go ahead and find the derivative of k. Say it, copy down exactly what you have, and take the derivative of the exponent, where the derivative of x is just 1. I have a to e to the x is my derivative. Pretty awesome, right? Pretty cool, pretty straightforward. Okay. Things are picking up a little bit now, right? Of course, right? Of course. It's a 5-week, 6-week calculus course. An awesome class, right? Hopefully. A prime. Say we're gonna copy. It doesn't matter what it looks like. You copy down exactly what was given to you. And then you multiply by the derivative of the exponent. What's the right? Remember, you can use zoom in if you want, right? You can zoom in. What's the derivative of negative 3x plus 8? Oh, that's just negative 3. Right? Meaning you can definitely multiply these two together. Meaning your derivative would be negative 9 e to the negative 3x plus 8. Right? That would be your derivative. All right. So it's always taking the derivative of the top. How about here? That's just well, I have two things with x's that are multiplying. And that's the hint, right? If you got two things with x's that are multiplying, that automatically is product rule. If you got two things with x's that are dividing, that is quotient rule, right? So for product rule, right? The product rule, right? I know that's f and g. So f is the first one. The derivative of that one would be 9x to the 8th. Right, g would be e to the 7x, and g prime, right? What do you guys think it's going to be? You can pause the video. This here would be 7e to the 7x. Right, applying the definition of the derivative, it'll be right the derivative of b prime, right? The derivative of b prime, right? I'm going to go ahead and write down the formula, right? The formula is in the cheat sheet I provided. It is e to the 7x times 9x to the 8th plus to the 9th times 7e to the 7x. Right, simplifying this a little bit, right? This means my derivative of this function is 9x to the 8th e to the 7x plus 7x to the 9th e to the 7x. And like I said, right, you could be like, hey, what if I wrote x at the end and e exponentials in the front? That's okay, right? All these three things are multiplying. And as long as they're multiplying, you can shuffle them however you want. Like I said, there's more than one right answer, right? There's more than one right answer. All right. What we would go ahead and do for both of these is Here on the top one, you would go ahead and apply the product rule, right? And the bottom one, you would apply the quotient rule, right? I'll go ahead and get these started for everyone. For the top one, right? It's these two are multiplying, right? So it's going to be f is going to be x squared plus 9x minus 3, meaning f prime is 2x plus 9, meaning g is, what did I write here? E 7x plus 11, e to the 7x plus 11, meaning g prime is 7e to the 7x plus 11, right? I'll go ahead and let you all plug it into the formula. And similarly with D, right? Similarly with D, I'm confident that you all know how to solve these and pull these straight out from the book, from your textbooks, right? From the videos I provided, from your homework. But yeah, very, very nice, right? It's just repetition, right? That's how we get these through, right? Repetition. Oh yeah, question I wanted to ask, right? Eventually, right, in the next homework, right? Because for exam 2, it's going to be very heavy on derivatives, right? For the upcoming assignment, it's just a little puzzle here, right? What function could have had negative 20x plus 15 as its derivative, right? So in other words, this is the derivative. This is the derivative. What could have been your original function? I'll let y'all, original function. I'll let y'all think about this for a minute. All right, if this is now a 1, meaning it was probably a 2 before, meaning whenever we brought that 2 down to the front and multiplied, so I would have to divide, right? And you can check, right? Derive this and make sure it gives you this. Right? Oh, and this is a coefficient, right? Meaning whenever you took its derivative, coefficients, you have just an x attached to it, right? So very, very, very nice. Right, and last section, right? Logarithms, natural logs and logarithms, taking derivative of those functions, right? Taking derivative of those functions. I'll go ahead and start off with the first one, right? The derivative of natural log of x is 1 over everything. Well, again, this again, y prime, there we go. The derivative of a natural log, it's going to be 1 over everything inside that parentheses times the derivative of what's inside the parentheses. Well, that's just 1. So meaning the derivative of natural log of x is 1 over x. All right. So for the first one, if you see that I have a function that's hugging, that has parentheses around a function, and you see d over dx, that's instructions for you, the mathematician, to derive that function, right? To derive that function. All right. One thing that you'd know is if I need to derive that, this is just the coefficient times the derivative, right? This is what I need to go ahead and take the derivative of. So we said that's 1 over x times the derivative of x, meaning my derivative is just 1 times 1 over x. It's 5 over x. Very, very nice. All right. Let's go ahead and step it up now a little bit, right? The derivative of this natural log function will then be 1 over everything in the inside times the derivative of the inside. The derivative of the inside would be what? 49x to the 6th minus 2. All right, meaning my final answer, right? I multiply these two together, all right? This would be 49x to the 6th minus 2 all over 7x to the 7th minus 2x. That right there would be my final answer. All right. So another thing I wanted to go and mention, right, is double derivatives, right? We went over that, double derivatives, right? Meaning I'm going to go ahead and take the first derivative first, right? It want me to find the second one, but hey, it's a step at a time, right? I need to go ahead and find the first one. Right, this is 10 times 1 over x. So this is just 10 over x. I need to now take the derivative of 10 over x. Hey, why does that sound very familiar? Like I've done it. Because we have, right? Because we have. We said if you want to take the derivative of anything with an x, you do not want it in the denominator, right? You do not want it in the denominator. So you're going to go ahead and rewrite this. You're going to go ahead and rewrite your first derivative. 10 over x, that is the same thing as 10 times x to the negative 1. Then you're going to go ahead and take the derivative of that, right? Hey, this is just power rule, right? If I were to take the derivative of the first derivative, here would be negative 10 x to the negative 2, right? 10x to the negative 2. And the great thing about that is that if you do not want that negative 2 as an exponent, now you can throw it to the bottom, right, to make it positive. So in other words, my second derivative is now just negative 10 over x squared. But they want me to find the second derivative whenever x equals 2. So this is negative 10 over 2 squared, which is negative 10 over 4, which is negative 5 over 2. So that would be my derivative at that given point. All right. So I have this other function, right? Going back to natural logs, right? Going back to natural logs to take the derivative of this, of a natural log. It is 1 over everything in the inside. Times the derivative of the inside. Right, meaning my derivative would be 2x plus 2 over x squared plus 2. Right, I'm going to play a few things here, right? I have a few of these. Regular derivative, regular power rule. Right. What's going on? Look at this again. You got two things that are multiplying. So this here, it means you need to apply product rule. All right. So you can go ahead and pause the video, right? Go ahead and attempt it on your own. And I'm going to go ahead and solve this to make sure you get the final answer. So then this here would be 4 times 1 over x, which is just 4 over x. For the second one, I need to go ahead and apply product rule. All right, so what I do is g, which is natural log of x, times the derivative of the first, which is the derivative of f, which is 14x to the 6th, plus the second, plus the first, times the derivative of the second, which is natural log of x. Right. And then going back to the last term here, right? This here would be just negative 5x to the 4th. Pretty much the mess that we need to clean up is this, right? So my first derivative is 4 over x plus 14x to the 6th times natural log of x plus 2x to the 6th. Y to the 6th? You have 7 x's on top and you got 1 at the bottom. They're going to cancel each other out. And that right there is my final answer. All right. I have another one. And I want us to think about this one for a bit. You may be saying, right, one route you can take, it's going to take you very long, by the way, is 1 over everything in the inside times the derivative of the inside. But you may be asking yourself, hey, I have a fraction I have a fraction there that I know what that means, man. That means I'm gonna have to go ahead and apply quotient rule. That's gonna get really, 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 really complicated, right? What was the hint I gave us in the very, very beginning? One of our lectures before was simplify this. If you have multiple terms in the numerator being divided by just one thing, rewrite this, right? This here was just natural log of x cubed over x squared plus 2 over x squared, right? meaning this here is just natural log of x plus 2 over x squared, but you can bring that x squared to the front and make it negative. That looks much nicer, and I can guarantee you it's going to give you a much nicer answer than the one we were going to attempt before. All right. So the derivative is going to be the same thing. 1 over everything in the inside times the derivative of the inside, which is 1 minus 4x to the negative third. So this here gives me 1 minus 4x to the negative third over x plus 2x to the negative 2. And that right there is my final answer. No quotient rule, none of that, right? And this is what I said. This is what I said. That's right. Whenever we're doing that, it's this hint, right? The hint we did for this problem. It's gonna have its benefits, right? It's gonna have its benefits. So when it comes to calculus and stuff, so very, very, very nice. Thank you, thank you, thank you. Very, very nice. Alrighty. And power rule applied. Chain rule applied with logarithmic, right? Well, guess what? It's the same thing as before. The only thing that changed is what's in the inside. All right. The inside part is this, and you'll find out why it's called chain rule, right? You're gonna go ahead and find out why it's called chain rule. It's like those Russian dolls, right? The Russian dolls, you have a little one inside a bigger one, inside a bigger one, and inside a bigger one, right? Right, and that's just the same thing. You're gonna have to take the derivative of the big one, then the smaller one, and the smaller one until you exhaust all possible derivatives, right? So the outermost, right? So whenever you're looking at chain rule, you're gonna look at your outermost part, and you'll find out that the 7 can go to the front. Meaning this is 7 times natural log of 8x. But then you have to ask yourself, now you need to take the derivative of the inside. Okay, so now what you're looking at is taking the derivative of natural log of 8x. Right, the derivative of natural log of 8x, that is 1 over what's on the inside of the natural log times the derivative of the inside of the natural log, which is 8. All right, those were the rules for natural log, right? It's a derivative within a derivative, all right? So then, these 8's cancel out, leaving me with just 7 natural log of 8x. Oh, to the 6th. I'm sorry, this should be a 6th up here. The 6 times 1 over x, meaning my final answer would be 7 natural log of 8x raised to the 6th all over x. Ta-da, that would be my final answer, right? So this was chain rule, but applying logarithmics to it, right? Applying logarithmics to it and stuff. So that is all I have for this week. This covers homeworks 8, 9, 10, 11, 12, 13. Be sure to submit your assignments on time, right? 1 PDF file. Excellent work, everybody. Keep up the hard work. And if you have any questions, don't hesitate to contact me. Thank you very much, and I hope you enjoy the rest of your day.